Hi viewers. What we have here is an initial attempt to create deposition of nickel 2 hydroxide on white halloysite clay mineral. We're using Dragonite, which is the registered trademark assigned to Applied Minerals Incorporated in Utah. They have a quarry where they are able to produce this ultra white halloysite. Very low iron, minimal iron content, which is a problem with batteries and supercaps with halloysite. You want the iron-free material. In this preliminary experiment, you're looking at it as it's forming a paste. We're going to put it in the oven and dry it at 75 degrees for 24 hours, quite arbitrarily 75. We reacted nickel to acetate, tetrahydrate, and we elected in this experiment to use 2.75 grams of this nickel salt. We dissolved it in a minimal amount of water at 20 degrees Celsius. And then in a separate transaction, we took 5.0 grams of the halloysite. We did not sieve it, we did not dry it, it's right out of the bottle. And we placed that in about 30 milliliters of distilled water. So we stirred this very, very well on a hot plate stir at 20 degrees Celsius. And slowly added the nickel acetate salt to the slurry of the halloysite, which of course it's nanotubular and it does not behave in a simple situation suspended in water like many other clays. And we added the nickel acetate, stirred well, and began adding from a burette 1.0 molar potassium hydroxide solution, aqueous solution. Adding it dropwise, but at a nice pace. Monitoring the pH. We were about 6.0 at the start. We finished up at about 9.5, quite arbitrarily. We don't want to go much higher than that. And there was a subtle change in the coloration of green. Now, nickel hydroxide is lime green when you have it in front of you pure. But of course, we're using the amount of nickel acetate, tetrahydrate, with 5 grams of the halloysite. But there was a subtle change in color. So we're going to dry this out. Now, the reason we're doing this, we're going to be making graphite felt composite electrodes, and we want to see, at least with the scanning electron microscope, how this material looks when it's dry, and then we will bind it to graphite felt. We also want to do cyclic voltammetry. We're looking for indication of psuedocapacitance. Pseudocapacitors are a type of supercapacitors, and we'll probably look at asymmetric. So in other words, we would have a composite with this on one of the graphite felt electrodes and not on the other. But we might do a symmetric one as well. But we're very interested in seeing how this material looks when it's dry upon magnification. We'll keep you posted on our research. Bye for now.